Good afternoon, and welcome to the webinar. My name is Kurt Smith with Applied Pavement Technology, and I'll be serving as your host for today's webinar on maintenance and preservation treatments to improve sustainability. This is part of an ongoing series of webinars on sustainability that were developed under the FHWA Sustainable Pavements program and covers all stages of the pavement life cycle. Before we get started, I want to mention just a few housekeeping items. This webinar is scheduled for a total of 1 hour, consisting of a 45-minute formal presentation and a 15-minute question and answer session. The questions will be answered at the end of the formal presentation, but you may submit your questions at any time during the presentation using the questions box on your control panel. If you don't see the questions box, you may need to click on the orange arrow icon on the control panel to display the settings as mentioned in the slide. At the end of the session, we will work to answer as many of the questions as we can within the time allotted. For those questions that we do not get to, the panelists will prepare and post responses to all attendees, and we will notify you when those become available. At the conclusion of the webinar, a copy of the presentation will be shared with all registrants via email, along with a link to the webinar recording once it is processed. You may need to regularly monitor your spam or junk folders, as we are discovering that some of our webinar communication for the registrants occasionally gets redirected there. Throughout today's webinar, we'll be using a number of acronyms referring to different materials, products, and processes. We'll work to introduce these as they are used throughout the webinar, but this master list will be available in the presentation that we will share with you later. With that, I would now like to introduce Monica Urado with FHWA, who will preface our webinar with a quick look at FHWA's Sustainable Pavements program.
Good afternoon and good morning to some. My name is Monica Jurado, and I want to thank you for joining us for the Sustainable Pavement Systems webinar series, and welcome you to our 5th webinar, Maintenance and Preservation Treatments to Improve Sustainability. The presenters for today will be Migdalia Carrion and Tom Van. Before we get started, I want to give you a little bit of background for the Sustainable Pavements program. The program began in 2010 with the vision and mission to advance the knowledge and practice in designing, constructing, and maintaining more sustainable pavements through stakeholder engagement, education, and the development of guidance and tools. With that in mind, we developed the Sustainable Pavement Systems, a webinar series, and today is the 5th out of the series of 10 webinars. You will receive 1 professional development hour per webinar, and upon the completion of 8 out of the 10 webinars, you will receive a course completion certificate. With that, with the program, we also had the Sustainable Pavements Ambassadors, and their mission and vision is to enhance the mission and goals of the Sustainable Pavements program within their discipline. And with that, I would like to introduce Ms. Migdalia Carrion, who in 2018 joined Federal Highway and oversees the Pavement and Materials program for the Puerto Rico division. In 2014, Ms. Carrion began working for the Puerto Rico Highway and Transportation Authority in the Bridge and Design Office. And in 2017, as the program manager for the MOU program and the Puerto Rico Transportation Asset Management Plan. And with that, I'll hand it over to Mrs. Carrion.
Thank you, Monica. And as Monica was saying, this is part of a webinar series in which some of these first slides might be familiar for some of you who have joined us for previous webinars, and a good introduction to those folks that are joining us new. In today's presentation, we are going to talk about the basics consideration and understanding of what are the most important aspects of achieving a sustainable pavement, and what are those techniques that we can apply to pavement and get you into a sustainable thinking at the time to take decisions with respect to those techniques. So let's begin by explaining why all of us, regardless of our title, position, or background, should we care about pavement sustainability. First, let's talk about the definition FHWA has set for sustainable pavement. It is important to mention that this definition was done as a collaborative effort between internal and external FHWA stakeholders, such as the concrete and asphalt industry and the academia. It is important to have a definition that we can all share and use. First, so we can start sustainable thinking throughout all the phases of the pavement life, but also because sometimes it's hard to define sustainable pavement when we are looking into the large infrastructure system. So let's talk about some of the benefits of being more sustainable. This can be divided into three main categories, all pillars of sustainability. These are economic, environmental, and social categories. This slide shows some examples into each category. Reducing the cost is a benefit that those that are engineers know very well, but there are other benefits into the environmental and social categories that we should all be aware and consider when we are taking decisions on what techniques is better suitable to apply to our pavements. So if we use this image to symbolize all the phases into the pavement life cycle, the message here is that there are opportunities in all of the phases or stages to be more sustainable. But today's presentation and today we are going to be focusing only on these phases, the maintenance and preservation phase. So let's dive a little into what is pavement preservation and some of the different treatments that are available to be used in our roads today. Pavement preservation is inherently a sustainable activity, employing maintenance, preventative maintenance, and minor rehabilitation treatments normally tend to be lower in cost and lower in environmental and social impacts than, for example, if we decide to do a reconstruction activity. The overall philosophy here is keeping good roads in good condition. So you might have seen this graph in the past if your background or job is something relative to pavement engineer, but let's explain it for those that is the first time seeing it. The graph is illustrating how pavement condition goes from good, excellent, to a failed condition over time. If you don't do nothing, this curve shows the normal progression of the condition of any pavement. Today, I want to focus into providing you with a perspective of sustainability. And the idea behind here is that if we treat a pavement when the condition is still good, still on this green aspect of the graph, then we can extend the pavement life into what we can call infinite life, instead of letting it fail and then having to reconstruct, expending big amounts of money, time, and resources to returning it to a good condition. Doing preservation activities can help extend the life of the pavement with less environmental, social, and economic impacts that when you compare it with other alternatives. When selecting the preservation technique to apply in any certain pavement, there are some factors that we consider or that at least we should be aware of them and how they impact our decision making. There are some factors that are typically considered on the engineering performance. Some of them like pavement type, the distress, the cost. But there are other factors that we also should be aware and consider as well, as traffic management, material availability, as, for example, longer haul make more impact to the environment. So let's talk about the impact on choosing the right treatment which in choosing the right factors and taking them in consideration will dictate how you reach your desired performance. These are some of the benefits impact of choosing the right treatment for the right pavement. Preservation is not a solution for all pavement, but choosing the right solution for the project might get you additional benefits into all three categories that we previously spoke about. Some of the ones presented in the slide are economical, others are environmental, such as reducing the noise, as well as social impacts, such as enhances aesthetics. Knowing your surroundings and your particular conditions will make choosing the right treatment easier. So let's make a distinction between preservation on low volume roads and high volume roads. When we have a pavement on low volume road, the use stage impact is less important than, for example, the agency impact. Thus, we could say or we could expect that the agency impact will dominate the decision-making process. But now, when we are on a high volume road, the use stage impact get to dominate, and here the social impact get to be forefront and should be considered. This distinction is important. When you are on the decision-making process, you should consider all the important factors to achieve a more sustainable pavement. We can stipulate that in general terms, preservation treatments will have less impacts than other treatments as previously mentioned. In summary, agencies typically focus on minimizing the cost of the pavement life cycle, which might be appropriate for low volume roads, but let's remember that for high volume roads, broader sustainability impacts should be taken in consideration. Now, I would like to introduce my peer, Tom Van, who is Federal Highway Pavement Preservation Program Manager. He has many years of leadership in the field of pavement preservation, including efforts such as Federal Highway EDC Pavement Preservation, When and Where, NHI's Pavement Management Course, and the MAP 21 Pavement Performance Measures. With that, you can continue, please.
Thank you, Medalia. Let me get my screen set up here for you here, and I'll be just 1 second. Be right with you on that. Okay. Oops, backwards. Okay, as Medalia was saying here, we want to look at some of the link between sustainability elements and the preservation practices that are pretty common in the United States today. The goal out of all of these practices is to look at lengthening that cycle between reconstruction and while maintaining all the expectations we have for the highway. And that's not only economic, but also the environmental and the social aspects as well. We recognize right up front that preservation is not a solution for every situation, but it can have some significant benefits when it's used at the right time. Some of you may have heard the mantra that we've had of the right treatment on the right road at the right time. And a lot of this applies not only to the economics, but also to the other elements of it as well. This afternoon, we're going to separate this between asphalt pavements and concrete pavements. So with that, let's try to begin with looking at some of these treatments and what they do and how well they can fit into this overall program. So the first of the treatments is the relatively easy one. These are low cost on it. It's actually a little bit more of crossing over between maintenance and preservation on this. Process is not too hard, usually not too expensive, but it is important that it be done correctly. And by being done correctly, that means that it needs to have the pavement crack cleaned out before you put the material in there. Typically, these materials are either a hot applied asphalt or else it's some kind of a silicone rubber sort of a material that goes into it. The second item here is, taking one step up the ladder here now is getting into patching on asphalt pavements. Frequently, this is done just prior to doing some kind of a larger preservation activity. For example, you might do a patch and then apply like a microsurfacing over it or something. So a lot of times this is something that you might have to do where most of the pavement's in pretty good shape, but you have just some selected areas that have gone and have been deteriorated for one reason or another. Another very common treatment these days is the fog seal rejuvenator. These are very useful, where oxidation is a problem. Basically, what this process does is it adds in a lot of the things that are in asphalt materials that tend to dry out over time. It's frequently used for preserving shoulders on high traffic highways. You may have seen some of this activity going on. Relatively easy to do. The only issue that you have to be careful of here is that the surface will become slippery when you put down this rejuvenator or fog seal. So you have to be very careful when you do it. And there are some practices that are typically done that increase the roughness and monitor it very carefully when to make sure you don't have any issues related to safety on that. The next treatment is one I think everyone has seen. These are the typical chip seals that are out there. People either like them or they don't like them, but they do have some pros and cons in using them on that. Typically, you'll find that chip seals are low cost. They do provide a very effective seal on the roadway. They cover many, many problems in the pavements. So, a lot of distresses and that kind of thing. Sometimes on very low volume roads, it tends to be the only surface that's put down. In some locations, they have done that and very successfully. One element of it that's very positive is that you generally will increase skid resistance on the roadway, when you put down a chip seal. On the other hand, they're not very popular if you're a bicyclist, and I think most of us remember growing up as a kid when you fell off your bicycle and ripped your pants on the pavement. It was probably a chip seal. Skateboarders really don't like them, because you really can't skateboard on a chip seal very well. And if not done properly, some of the stones can break loose and damage the windshields. If that's done properly, you don't really have that big of a problem. Typically, you'll find these kind of treatments will last for 5 or 6 years at least. In some places, they've actually done quite a bit more than that. The next treatment that we have is a slurry seal. And this is a little bit different than a chip seal. This is where the stones are mixed in with the asphalt before it's spread. Typically, these use a little bit smaller aggregate, so you get a little bit smoother surface, and that makes them a little more amenable in urban areas as well. But there are some issues with that. You do need a special spreader to put it down. It does provide a good seal. It can be placed in different thicknesses. You can add a little bit of thickness to the roadway and correct some of the profile issues in there. It's useful on the roadway if you don't have too many cracks in it. Just one other element I wanted to talk about is if you take and add a chip seal and a slurry seal on top of it, you get something we now call a cape seal, which is a combination of those two, and those are becoming increasingly popular across the country. The next surfacing we'll talk about a little bit is microsurfacing, and this is a little bit similar to a slurry seal, but it is done usually with more select materials and very, very careful placement when it goes down. It is a lot more costly because of those select materials that go down in it, but a surface like this can last as much as 10 years or even more in some locations. Sometimes they use these microsurfacing projects to correct running problems, and it can be used on the roadways where there's some high traffic levels as well. Moving on here, the ultra thin and thin asphalt overlays. Now here you'll notice we're talking about some overlays that are pretty thin here. Notice in here that some of these are less than an inch and a half thick on it. So These are becoming popular, particularly in the urban areas. Typically, when these are done, an agency will do a little bit of a micro milling down and try to get it so it matches the curb lines and that kind of thing. Put the overlay down, and it's very effective where the pavement structure is fairly good, but the surface might be worn from traffic or some other reason. These tend to be extremely effective in there. They tend to give you a good surface at a lot less impact than some of the other activities that we might run into. Okay, let me get my pages straightened out here. Okay, hot and place recycling. This is one of those activities that's not done a whole lot around the country, but we do find that very popular in certain areas there, particularly where traffic, where trucking is a really big issue. It's not necessarily a preservation treatment, but it is valuable in terms of some of the sustainability elements of it. This is basically a case of where you're reconstructing the surface from what's already out there and adding in a little bit of material of asphalt and some other additives, to restore that asphalt back to a very good condition on it. It's a little bit expensive to do, but as I said before, where trucking is really a big issue, this can be a very cost-effective element to do. This is one of the kinds of things that I recall doing back when I was an engineer out in Nevada, and it was 50 miles to the nearest asphalt plant. So it made hot in place recycling something that was very practical to do on a lot of these kinds of roadways. Now we also have the other element, which is called cold in place recycling. Now this one, typically, as you can see on the slide there, it talks a little bit about doing this stuff with cold milling. You don't use a lot of heat in this element, in this activity that's going on with it. It's not as durable as the hot in place recycling, but then again, it has a lot more application when you're out in remote areas. A lot of times, this is used to correct small areas of rutting and some other problems that you might see out on some of these roadways in these remote locations. This is often used as a solution where there's not enough work to make a more expensive kind of repair practical. The ultra-thin bonded wearing course. This is really a specialized version of the thin overlays. And if you recall back a couple slides, we talked a little bit about how some of the ultra-thin overlays were out there. And now, a wearing course is intended to be on the surface there. These are often placed in very high traffic highways. You'll see them on interstate highways, see them on urban freeways, and some of that. Frequently used a lot to improve safety and extend the life of the pavements. The safety improvements are usually related to friction improvement on there and correction of things like rutting and elements to that. These do require a lot of attention to detail, but the surface can take a lot of abuse, and they tend to last for a long time on the roadway. Okay. Now we talk a little bit about bonded concrete overlays in here. You may not have seen these used too frequently in your location, but they do have some use for special situations, such as where asphalt pavement is not holding up. For example, you may have some areas where the pavement is shoving because of trucks turning on a curve or something like that. Some places you have extreme rutting, and it's very difficult to control. Another typical use that has been done with them is as bus stops, because where buses stop and sit, they tend to drip oils and things like that tend to be very deleterious to asphalt surfaces. The process is really not too difficult. You mill the surface, you put down this concrete layer, you cut it into some joints here to make them that are like about a 4x4 joint or so something of that nature on it. Now, I've had some experience with this. We did one of these up in New Jersey. It was on an off ramp where the trucks had come around it, and it was difficult because the roadway kept shoving off there, and the state had to go back in and replace that pavement almost on a yearly basis. And after we put this bonded concrete overlay on that, we had gone back after about 5 years, and most of it was still in pretty good shape. Some of it had a few cracks in it, but the one thing I was surprised at is that there was no no problem with the asphalt and the pavement, holding together. All of the cracking and things like that was due to other reasons that were out there. These are very durable solutions. They can very easily last for many, many years on it. Okay. So those are most of the common asphalt connections on it. So if we look at some of the values of what these pavement preservation treatments will do on there, you can see here that they have different issues with life and with cost and with impact, environmental impact and social impacts on there. So there's some significant value that you see in here, not only for the low cost ones, which I have on the screen now, but also on this next screen with some of the higher cost ones. You can see that as the cost goes up, the life extension expectations for that will also increase, and the benefits are there for pretty much everyone on it. So with that, let's talk a little bit about what's going on in the future here. The asphalt paving industry is not something that's static at this point in time. There's a lot of activities going on. So some of these things that we've seen out there are that the industry is working a lot on improved treatments. You'll see a lot of new kinds of materials. You see new kinds of polymers put into the asphalt. You see a lot longer lasting materials than we've seen in the past. Yeah. Agencies are working on treatment selections, that use a lot of their pavement management systems and will tend to allow us to have treatments that last longer, make the pavements last longer, and give us a better economic, environmental, and social benefit out of it. Now, the last couple of things are also a couple of things that you may have seen out there. Some of the improved practices, things like improvements in the paving machines. You see some issues in there. Some of the others you may have seen in there are things like intelligent compaction machines. There's some infrared temperature monitoring. Some of those things out there have really improved the preservation programs in a lot of the states that are there, that are using them. So let's talk a little bit now about the other kind of pavements, which are Portland cement concrete pavements. These are less common across the country because they cost more to construct initially, but they do have the benefit that they do last a long time, usually with a lot less attention than you do have with asphalt. Yeah. I'm going to go over some of the ways that we can make these last longer through preservation programs as well. So first off, we're talking again about joint sealing in here, crack sealing in concrete. This is really pretty easy thing to do usually. It's maybe more important in concrete than it is in asphalt because concrete slabs tend to expand and contract more in there. The goal of all the sealing is keep the water out because the water in the subgrade does do a lot of damage and shortens the life of it. The materials here, again, these are typically hot asphalt materials or could be a cold applied silicon material. Sometimes in concrete pavements, they do use these preformed compressed rubber that's used in joint seals on it. The most important thing here, like it is with asphalt, that the joint needs to be cleaned before it's in. So, you'll see the guys, using air to clean the things out and get the stones and the other incompressible material out of there that will damage the pavements as they tend to contract and expand. The second thing that you see done a lot is diamond grinding. Although concrete pavements can last for a long, long time, sometimes the surfaces will tend to get rough. Grinding can fix that, if the slabs are not broken and the slabs are stable in there. And you can see on the screen in front of you here some of the things that we try to address with it. It'll try to go into vaulting. It'll try to improve a riding surface that is sometimes even better than what we had originally on that pavement. Okay. Then we see bonded concrete overlays. Now, these are somewhat similar to the ones that we saw over asphalt, but this is where we put concrete over concrete on it, usually in a fairly thin layer on it. It's used usually where you have pavement that's mostly okay, but there may be some irregularities in there that's due to things like a utility cut. It could be some settlement or something like that, some similar kinds of damage in there. So these are relatively low cost as compared to replacing the whole slab out there, and they do get done in certain parts of the country where we have a lot of concrete pavements. It does improve the noise issues sometimes on there as well. Okay, so I talked about diamond grinding a few minutes ago. Now we have something called diamond grooving. Okay, is this a little bit different? And it really is, because it tries to deal with a different problem than the grinding did. Grinding was supposed to address those pavements that were not very smooth because of some reason in here. And the diamond grooving tries to address the other problem, is when pavements get too smooth from issues like aggregates polishing, or where we have some safety issues for some reason or another in there. It helps drain the water out. This is not always done in the direction of traffic. Sometimes they'll do it transversely across the roadway, and give some grooves in there that'll help with friction and help with deal with safety problems that do occur in pavements. Now, this is a little bit of a maintenance activity, I guess, and this is one way that agencies can deal with sunken slabs or some slabs that have become unstable on the highway. The process really amounts to drilling holes through the slab and then injecting some material to either raise the slab or stabilize it. And you can kind of see some of the materials on the screen here that we use with it. Don't get us wrong, this is a little bit costly to do, but it is less than having to replace the whole slab, and it is a lot less interruption of traffic and a lot more environmentally friendly than doing a slab replacement. Now, this kind of activity is, clearly a bit of maintenance in here, and it's a little bit self-explanatory. I mean, basically, we're repairing damage on the pavement. Usually, that looks like spalling is what we typically call it on there. I think all of you've probably seen some of this stuff at some point or another on these roadways. There's all sorts of specialized materials to do this work. Depends on how long you can close the highway, or how long you expect this repair to last, or what's going to go over how much traffic. And the folks who sell this kind of stuff have all different sorts of applications for doing it. So this does work. It's a very effective thing to do, much less expensive than trying to replace it, much more effective than trying to cover this over with asphalt or something else in it. Similar to the partial depth repairs, we talk about full depth repairs, very similar, okay, but it's usually a larger repair. Sometimes this will involve replacing all the way down to the base. Sometimes it involves putting in, replacing or installing some rebar steel and or some dowel bars, that get drilled into the existing pavements to replace that. Often this kind of work is done on interstate highways where closing the roadway for a long period of time would be difficult to do. As you can see on the slide here, it talks a little bit about restoring ride quality and structural integrity, and that's especially true if they follow this up with like a diamond grinding or something of that nature on it, just to make sure that those joints all are really smooth going across it. Now, dowel bar retrofits. You may have seen some of these out there. You tend to see these marks in the wheel path of the roadway. We had a lot of these repairs that were done a number of years ago because there were quite a few slabs in early on that did not have dowel bars installed at the time. More recently, we've been installing dowel bars in pretty much every concrete pavement that's out there, so it's a little bit less of a need today. But nevertheless, you do still see some of the work, this kind of work going on as well. It's an effective way to add some substantial life to the pavement. It allows that cross the joint support that you definitely need to carry the truck traffic on a major roadway. Now, cross stitching. This is one of these techniques where you address a situation where most of the pavement might be good, but you just have a couple cracks in there that are not related to loading, but got in there somehow or another. Maybe the concrete got poured on a day that was too hot or too cold or something in there. But it's a way to fix a crack on an otherwise really good pavement that you want to keep on it. If the crack is due to loading in there, you would not want to do this kind of a solution on it, as it would not work in it. But these are typically done. I've done a couple of these in a few cases, and they've been pretty effective on some of the roadways. Now, similar to the asphalt chart that we had up here a little while ago, there's some real value in these practices here in extending the life of the pavements. You can see in here some of the impacts that are expected for some of the lower cost fixes that we have on it, and then in the next slide here, you'll see for some of the more expensive costs ones, and in all cases here, they do really help to do things that are good for all of us on the roadway. And so, okay, so where is some of this going in the future? There is a lot of work going on, a lot of activities in concrete preservation. A lot of it gets back down to the actual design work initially on it, and then some of the preservation techniques that are out there. So some of the things, again, some of the improved treatments out there. The industry is working hard on this, trying to get things that last longer, like we put up here. Some of them that use less materials. Looking at a lot of them that can keep the lanes closed for a shorter period of time. That's a key issue when you have a very busy highway on it. Agencies are looking at trying to do a lot of the treatment selection using methods like pavement management systems, fitting these things into their asset management programs and their long-term designs. In concrete, we've talked about precast solutions for a long time, and up until now, it has not really been too cost-effective. But maybe now, as the cost of trucking and cost of materials, cost of labor is going up, maybe some of these precast things might in fact be an alternative that we'll be seeing a lot of in the future with it. So if we look at a summary on here and we think about some of the takeaways that we have on this program, if we look at our goals, keeping the good pavements good, keeping the smooth pavements smooth, quiet pavements quiet, safe pavements safe, and I'm sure you can figure a few more of those things. a lot of what we wanted to hope we conveyed to you today is that preservation can help achieve some of those goals. Keep that in mind as you start to do it, but also keep a look at how it fits into that whole pavement cycle of, you build it, you're going to do preservation at some point, you do maintenance at some point, and eventually, yes, it'll have to be rebuilt, but let's try to make that that time frame on the life cycle as long as we possibly can on it. When we build pavements, the thing we got to think about is a roadway. We build it; it tends to be out there forever. So what we really want to try to do is make sure that we can meet and maintain the goals for the expectations that people have for those pavements. And preservation really has to be part of that life cycle when we do that. And so with that, I'm going to turn this back over to Migdalia, and she can carry us through.
Thank you, Tom. To finalize, if you would like to have more educational material to share with your peers or any other agency, you can visit our website. The link will be provided in the presentation at the end. There, you can find Chapter 7 towards Sustainable Pavement System. That's the first link you see on this slide that discuss into more detail everything that we have discussed in today's presentation. There are other great material that will enable you with information to become a sustainable ambassador, as Tom and myself, and get the message out. In this first phase of the sustainable program, we are looking for getting everyone into sustainable thinking, and we want to get that message out to everyone and to take in consideration when you are doing decision making. Also, if you find that there is something that your agency is doing that you think will benefit from having a more sustainable approach, please feel free to reach out. Personally, I am working with the Sustainable Program in my state to develop a life cycle assessment case study here in Puerto Rico. Next slide, please. To learn about life cycle assessment and other topics, please join us for the next webinars that are on schedule in this webinar series. Here, you can click on the link to the previous webinar if you haven't attended, and keep an eye for the next one to come. Please spread the word and share with everyone you know so they can also come and participate from this webinar. Next. As mentioned earlier, As mentioned earlier, here is the website link and the contact if you have any doubt or question. If you don't have the link, you can also go to Google and do a Google search, put in FHWA Sustainable Program, and usually it's the top or second search when you go into the website. When you enter, if you see a lot of green, you're probably in the right website. That's another way of entering if you don't have the website at your hand. With that, this is the end of the presentation, and now I will give it to Kurt for the question and answer section.
Very good. Thank you, Migdalia, and thank you, Tom. We appreciate the information that you shared with us here today. We are in good shape with time. We've got about 15 minutes or so to entertain some questions, and we've had a number of them come in. Again, you're welcome to submit questions from now until the end of the webinar session. We will not be able to get to all of them, but we will make an effort to try to answer those and get back to everyone maybe in a couple weeks or so with some responses to all those questions. So why don't we go ahead and get started, and we'll try to share these among our various speakers, and we'll start with Migdalia. Migdalia, there was a question early on. You'd made a comment about the environmental impacts are context sensitive, and there's just a question whether you could elaborate on what is meant by context sensitive.
Yes, thank you, Kurt. So context sensitive means that when we are doing sustainable analysis, when we are looking at environmental, social impacts, for example, when you are comparing one treatment over the other, that comparison can be done for a particular project, for example, for a particular context. It is not appropriate to take that number, for example, that you have done in that project and taking it for another state, which the context may be different. So the idea of sensitive context, the context sensitive, is that when we are doing comparison, we can compare one treatment over the other on the environmental social impacts, but be careful not to take that and use it as a metric for other projects or even other states.
All right, thank you. Let's move on. Tom, there's a number of questions for you. We'll give you a couple at a time, and then I'll switch back to a few other speakers to give you a break. But let's start with one that was on the use of chip and slurry seals. The question was, what is the influence of chip and slurry seals on ride quality? Since both of those treatments create some friction, wouldn't that also lead to increased fuel use? Tom, I think you're muted. There you go.
I think I got it. They do increase friction. Would they increase fuel use? I suppose to a certain extent it would. From an environmental standpoint, I guess, we're doing a trade-off between that and the amount of fuel that gets used in creating a new hot mix asphalt surface and trucking the material out there. So I don't know if anybody has ever really quantified what that effect is just yet, but certainly an issue that is worth investigating. So I don't know if I really have a good answer for you on that one. So
yeah, and I think you're right. Certainly they do lead to friction, but that friction is, it's a microtexture type friction that doesn't have as significant an effect on fuel usage, fuel consumption, as the larger wavelength roughness, the longer wavelengths that would affect some of the fuel consumption. So generally, I would think that higher friction would have a very nominal effect on the fuel consumption of that particular type of application. The bigger thing is just the overall smoothness. That's really what you can quantify as having a significant effect on fuel consumption. Continuing on, Tom, in a related question, there was a question about whether crack sealing and or chip sealing caused any particular safety issues for like bicyclists or motorcycles, and how maybe that should be considered in the selection process.
I know I have heard some of that over the years with that, particularly with motorcycles in there. I think with bicycles, probably not a whole lot, because the speed of a bicycle is fairly slow in there. And I think there are many other issues, such as narrow lanes and things like that affect bicyclists a lot more than actually the pavement surface does in there. Now, on motorcycles, things like crack seals in there, if they're not installed properly and they have a big overband on them, they can get slippery when they're wet on that. And so there may be some need to be very cautious on that, particularly if it's on a high-speed roadway and roadways where there's a lot of curves and that kind of thing. One would want to be very careful on the installation of that. So in those cases, you might want to avoid doing a overband type crack seal on that. And so, Kurt?
Right. Yeah, and I think you're absolutely right. It is a function of the speed, too. Where you have the higher speeds, that's where it can be potentially more of a concern or an issue. Let's move over and bring in Monica. Monica, there's a question about just in general, for any pavement, what are some of the critical performance indicators and some of the associated thresholds? So in other words, what level of some of these defects or distresses can we tolerate before we need to start becoming concerned?
So we don't have anything actually written, and as per our reference document, we're trying to look more into some of these preservation and maintenance categories in order to try to prevent from getting to the point of where we have real concern or real, red flashing lights at us. So we're trying to do the sustainable thinking and looking ahead and try to preserve and maintain what we have. And then there are also some engineering forensics that we would be performing on some of these projects to look ahead and see where we're at. And this would be from some of the webinars that we had in the past, like at the design or at the scoping meetings and looking ahead.
Right. And certainly a lot of these different pavements and a lot of these different distresses have some critical values associated with them. For example, I know on concrete pavements, we often consider faulting of somewhere around the order of 1/8 of an inch or 1/10 of an inch as being something that's critical, that requires some kind of treatment. And I think in the literature, you'll find a lot of those types of general guidelines and general thresholds. But I think what we're also starting to see that was often driven from a performance perspective. What we're seeing from an environmental perspective, sometimes there are some significant advantages to maybe trying to get ahead of those and not wait till we cross those historically established critical thresholds, but maybe trying to catch them a little earlier and be able to reap some of those performance benefits. And I know, again, using the concrete pavement example with the faulting, some agencies have found by being able to diamond grind their pavements before even reaching some of those critical levels, they're able to maintain it in a very high level of serviceability, maintain very high levels of smoothness, which in turn then have some significant environmental benefits in terms of smoother ride to the public, and the smoothness also results in reduced fuel consumption.
And with that, that's also very context sensitive. So it's very project specific or agency specific. So there's not a one shoe fits all either.
Yeah, you're absolutely right. So why don't we move on and let's see if we can bring perhaps Heather into the conversation. Heather Dilla, heading up the Sustainable Pavements program. Heather, there's been some discussion just on looking at environmental impacts. And the question is, how do you actually assess some of these impacts, or how do you try to quantify these impacts?
Yes. To quantify the environmental impacts, we use a technique called life cycle assessment. And I'm not going to get into the details of life cycle assessment, but we do have 2 webinars that will be focusing on life cycle assessment, one in June and one in July. So I would recommend that you tune in for those webinars. We also have some information on the website regarding to what life cycle assessment is. But for pavement preservation products, if you are comparing 2 products that would have the same performance, you would want to look at an environmental product declaration to give you an idea of what the environmental impacts are of the manufacturing process and producing that particular pavement preservation product. But if they have different performances, then it's really important to look at it from the spectrum of the life cycle of the pavement and in comparison to what other treatment alternatives you would do if it's different performances between the 2 products. So it's very specific to what the life cycle assessment technique can be used, but it's specific to what goal and scope you're looking at to determine what questions you can answer with it.
Right. Okay. Very good. And that is kind of an emerging area right now. There's a lot of work, a lot of focus being done in that currently.
Mm-hmm.
Let's turn back to Tom. Tom, there's a question on for microsurfacing. If you crack seal before applying the microsurfacing, how long is it expected to last before cracking again?
That's a tough question to answer in a lot of ways because it depends a lot on how serious the cracking was before you put the microsurfacing down. If the cracks were wide, if the pavement was pretty well deteriorated, then it probably won't last too long before you see the cracks come back again. If the cracks are very minor in there, you could probably get 5 or 6 years before you saw cracks again in that.
All right, thanks, Tom. And can we follow up with you again on another question? Which type of monitoring do you prefer to assess the pavement condition, manually by survey type or digitally using imaging?
Well, let me put it this way. I personally would not like to be walking out on an interstate highway. But then again, if I'm in a local agency and there's very little traffic out there, a manual survey would be fine with it. I think a lot of it depends on the highways that you're trying to monitor. You want to be very careful with being out where there's a lot of traffic. I think that the safety issue is a big thing on that. Digital imaging costs a lot of money to do. That's the other part of it too. If you're already doing a lot of imaging for your highways, then it's not a big deal. If you're not, then it could cost quite a bit to just get started with that. So, like I said, if you're a smaller agency, if you don't have high traffic roads, manual's fine. If you do, you might want to really consider doing some automated data collection.
Right, and a lot of that technology has improved considerably over the last 5 years or more, and the ability to recognize and depict, some of those images on the workstation is improved considerably as well. So that's certainly been one advantage. And I think we also probably need to look a little bit about the application. I mean, if it's a network management type of application, I think most highway agencies are using some kind of digital imagery, using the automated data collection to use that to kind of drive overall network management programs. But then if we are targeting a particular project for some sort of an evaluation, we can perhaps use some of that network imaging or the computer imaging as a basis. But it seems like for specific project evaluation, there are definitely some benefits to being out there physically and taking a look at the pavement and kind of kicking it a little bit and getting a feel for what it looks like and how it's performing. Let's move on to another question. This one is for Heather. Heather, there's a question whether there's curious if any sustainability impact of hot applied versus emulsion chip seals has been documented or quantified in any projects or any of the literature?
Not that I'm aware. For hot asphalt, yes. The National Asphalt Pavement Association has an EPD program. They've worked on LCAs. So for asphalt, yes. For a lot of these pavement preservation products, no. I know that some of the pavement preservation associations do have calculators up on their website, but I don't know the background behind those calculators. So I know that they are engaged in getting on board with the environmental product declarations, which would be a better way to ask for some of this information. And so I think you'll be able to get this information more readily in the future, but I don't know of too many pavement preservation products that have environmental product declarations out there right now. And then particular for these different, to do a study on the different treatments, I don't know of many studies that look at those.
All right, very good. Well, I think we're bumping up against our time limit at this point, so I think we're going to cut things off right there. Again, we will post answers to all the questions that were raised in today's webinar, and we'll let you know when those become available. So thank you very much for your time and attention today. We hope you found the webinar informative, and we look forward to having you our next webinar presentation, which is scheduled for next month in March. So thanks for attending, and so long.